Unit 2, opener number 3, is about a scale, and this scale represents equality because both pans of the scale are balanced. So that means whatever's in the left-hand side of the scale must weigh exactly the same as whatever's on the right-hand side in order to keep the scale balanced. Well, on the left-hand side I see 2 pigs, plus I see 3 of these other things, and I'm totally embarrassed, but I actually have no idea what those things are. But I'm sure if the picture were a little bit bigger and I could see a little clearly, I'd be able to figure it out. But I'm going to call them weights, but they might be something else entirely. I really don't know. So for now, I'm going to say there's 2 pigs and 3 weights on the left-hand side. On the right-hand side, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 weights. So I can write an equation to represent this situation. I have 2 pigs, and I'm going to use P to represent the weight of each pig, plus 3 weights. That's on the left-hand side of the balance. Well, that's equal to what's on the right-hand side of the balance, which is 9 weights. Now, I could go through the steps and solve this equation algebraically, but I'd rather look a little bit more at my scale and try to solve this visually instead. So the next thing that I'm going to do is I'm going to remove the 3 weights from the left-hand side of my scale. The problem with doing that is now my scale is no longer balanced, because if I took 3 weights away from the left-hand side, now all of a sudden that side of the scale weighs way less than what's on the other side of the scale. So the only way to keep the scale balanced is if I do exactly the same thing on the right-hand side of the scale. So I'm going to also remove 3 weights from the right-hand side. So now what I'm left with on the left is I only have 2 pigs, and on the right, I'm left with only 6 weights. What I really did here, if I want to go back to the algebra, was I took away 3 weights from the left-hand side, and I took away 3 weights from the right-hand side. If you look closely on the left, 3 minus 3 is 0, so I'm going to cancel that out, and I'd be left with 2p, and then 9 minus 3 is 6, so that's what I'm left with on the right-hand side. Well, I can also look at my last step visually as well, because I have 2 pigs left and I have 6 weights. So if I want to figure out how much each pig weighs, I need to divide those weights in half. So I have my first pig, and then I have these 3 weights over here on the left, and then I have my second pig, and then I have these 3 weights over here on my right. So each pig must weigh 3 weights. Well, if I go back to my equation and I want to take a look at this algebraically, what I did to those 2 pigs was I divided each of those weights in half. I divided both sides by 2. Well, this matches up with what we saw visually, because 2 divided by 2 is just 1. So I'm only left with 1p on the left-hand side, and then 6 divided by 2 is 3. So each pig is equivalent to 3 weights. This is a good visual example of solving equations. Think about this balance every time you're solving an equation algebraically. Whatever you do to the left-hand side of your scale, you have to do to your right-hand side of your scale as well, or else your scale will no longer be balanced. When you're solving an equation, you always want to make sure to keep your scale balanced.